Pythagoras' theorem, finding shorter sides of a triangle. Before we've learned, or in previous lessons, we learned how to find the value of the hypotenuse using Pythagoras' theorem. We can also find the value of the shorter sides. So in these questions, you'll see that they're not asking me for the hypotenuse, they're asking me for shorter sides. There are a couple of ways we can do this. They all use Pythagoras' theorem. Let's start by assuming that we just write Pythagoras' theorem as c squared equals a squared plus b squared. That's how we've been writing it. Our steps, we know, are write the formula, substitute the values. Now we have to be careful here. Label our sides. The hypotenuse is always c. They've already given us a, so this one must be b. Because you see, when we're substituting in, we know the hypotenuse this time. C squared is 25 squared. We don't know a squared, so we leave it. And b squared is 15 squared. What we need to do then, we've substituted our values. We evaluate. 25 squared, grab your calculator if you need to. 625, we still don't know a squared, plus 15 squared, 15 times 15, 225. Now you'll notice in my steps before I said evaluate or solve or simplify. We don't know what a squared is yet because it's in the middle of an equation. So one way of dealing with finding a shorter side is just to use Pythagoras' theorem and end up with an equation that we have to solve. I want a on its own, and I start with the pluses and minuses that I have to get rid of. I have to get rid of that plus 225, so I take away 225 from both sides. Take it away from there, and take it away from 625, which leaves me with 400. 400 isn't a though, 400 is a squared. You'll remember to get rid of a squared, we do the square root of both sides. That will be a, and the square root of 400 is 20. Now I've got this the wrong way round, but it doesn't matter. If 20 equals a is 20. Check that it's shorter than the hypotenuse. Yes, it is. Had to be. And we're done. So that's finding a short side just using Pythagoras' theorem the way that we've learnt it. But we could use a rearranged version of the theorem so we didn't have to rearrange in the middle of our sum. If c squared equals a squared plus b squared, think about if I said 5 equals 2 plus 3. Does that mean that 3 is 5 minus 2? Yes. So the two short sides added together make the long side, but if I wanted to find the two short sides squared added together make the long side squared. If I wanted to have the short side squared as the subject, it would have to be found by doing c squared minus b squared. Always put our c squared first. I'm taking the short side squared away from the long side squared. So the theorem a squared, or the formula a squared equals c squared minus b squared is still Pythagoras, but it's for finding shorter sides. Sometimes when the questions get tricky, this theorem won't make your life easier. So only use it, this version of the equation. Only use it if all you need to do is find one short side. There's some tricky questions where you'd think this is what you'd do because you're missing a short side, but it's not very helpful for you. It will still work, it just gets confusing. If you're ever confused, go back, to the original theorem. But let's use this one. A squared equals c squared minus b squared. Substitute our values. We don't know a squared. C, we didn't label our sides. C, b. C is 17, so that's 17 squared minus 15 squared. Now you see we don't need to rearrange anything. We can just work out 17 squared minus 15 squared, and we get 64. Now that's a squared. That's saying a times a is 64. We could probably work this out without using a calculator. What number multiplied by itself gives me 64? Of course it's 8. So the square root of both sides, a equals 8. Check that it's shorter than the hypotenuse. Yes, it is. We're done. The last question, you might like to try it on your own before you watch this through. Now I am going to give you a different version of the formula again. Again, it's just if you happen to like this one. This one puts the square root in the formula. A equals the square root of c squared minus b squared. Again, don't use this one if you're at all confused or if you think it's a hard question. Only use it if you're sure all you're doing is finding the short side. Now, we could write it like that, or we could write b equals the square root of c squared minus a squared. Either one is fine. And in fact, we can write the original theorem as c equals the square root of a squared plus b squared. It's just putting the square root in the theorem. So any of those are fine. You don't need to use these. You can always just use the original theorem, c squared equals a squared plus b squared. Choose the one that finds the side we want, b. B equals the square root of c squared minus a squared. Label our sides, substitute our values, and you can actually type this in and go straight to answer B. Remember that because my square root sign goes all the way across, it means I have invisible brackets around this. So if you type it into your calculator, you must use those brackets. Calculators don't remember about invisible brackets all the time. B equals the square root of, and you put your brackets in, 10 squared minus 7.6 squared. Finish your brackets, and we get 6.5, and it's millimeters because there were millimeters in the question. 3 different versions of the equation of the formula for Pythagoras. All of them will work to find a shorter side. Up to you which one you think you'd prefer to use.